Leaves are everywhere, falling from trees, shading sidewalks, and quietly doing their job without much attention. But if you've ever looked closely at one, you've probably noticed the thin branching lines running across its surface, almost like a tiny road map. They might seem like simple patterns, but they're actually essential to a leaf's survival. So why do leaves have veins? Today we're uncovering the hidden purpose behind these natural pathways and the science that keeps plants alive. Right here on History of Simple Things. People have been observing leaves for thousands of years, mostly for practical reasons like medicine, farming, and food. But scientists didn't fully understand what was happening inside them until microscopes improved in the 1600s and 1700s. As botanists examined leaves more closely, they discovered that those visible lines were actually transport systems carrying water and nutrients. That discovery helped reveal something remarkable. Leaves aren't just simple green surfaces, they're highly organized living systems built for survival. To understand why leaves have veins, we first need to understand what leaves actually do. A leaf is essentially the plant's food-making factory. Using sunlight, water, and carbon dioxide, leaves perform photosynthesis, the process that creates sugars the plant uses for energy. You can think of leaves as natural solar panels. They capture sunlight and convert it into chemical energy. But just like any factory, they need a delivery system. Raw materials have to come in. Finished products have to go out. That's exactly what veins are for. Leaf veins work like tiny pipes. They transport water and minerals from the roots up into the leaf. Then they carry sugars produced by photosynthesis back to the rest of the plant. This transport happens through two specialized tissues, xylem and phloem. The xylem moves water upward. The phloem carries sugars and nutrients throughout the plant. Together, they form a miniature transportation network built directly into every leaf. Without this system, photosynthesis couldn't happen efficiently. One of the biggest jobs of leaf veins is delivering water. Plants absorb water through their roots. That water travels upward through the stem and into the leaf veins. From there, it spreads into leaf tissues where it's used for photosynthesis. This movement happens partly through something called transpiration. As water evaporates from tiny pores on the leaf surface, it creates a pulling force that draws more water upward. It's a bit like sipping through a straw. The leaf is constantly pulling water from below. Leaves don't just receive materials, they also send products out. Once photosynthesis produces sugar, that energy needs to be distributed. The phloem acts like a delivery service, transporting sugars to roots, stems, flowers, fruits, and growing shoots. Some parts of the plant need energy immediately, others store it for later. Without veins, all that food would remain trapped in the leaf. Leaf veins do more than transport materials. They also act like a support framework. Leaves are thin and lightweight. Without internal reinforcement, they would droop, tear, or collapse easily. The larger central vein, called the midrib, acts like the backbone. Smaller branching veins add stability. This structure helps leaves stay spread out, maximizing exposure to sunlight. In other words, veins help keep leaves properly positioned to capture solar energy. Not all leaves have the same vein design. There are two main patterns. Parallel veins. These run side by side from base to tip. They're common in grasses, corn, and many monocots. Netted veins. These branch into interconnected networks. They're common in trees, shrubs, and many flowering plants. Each pattern reflects evolutionary adaptations. Parallel veins are efficient for long, narrow leaves. Netted veins provide flexibility and redundancy. If one pathway is damaged, others can still function. Leaves often face damage from insects, weather, or physical tearing. Vein networks help limit the impact. Because nutrients can move through multiple roots, damage to one section doesn't always disable the entire leaf. This built-in backup system increases survival. It's similar to having alternate roads during traffic. If one route is blocked, another can still carry the load. Ever notice how some leaves have bold, obvious veins while others look smoother? Visibility depends on several factors: leaf thickness, pigmentation, species, and light exposure. Some plants evolved highly visible veins because they need stronger structural support. Others have thinner leaves where veins are less pronounced. In certain ornamental plants, contrasting veins even help with light distribution inside the leaf. Nature often combines function with beauty. Leaf veins aren't randomly arranged. Their branching patterns often follow mathematical principles found throughout nature. These include optimization systems that maximize efficiency while minimizing material use. In simple terms, plants have evolved to build the most effective transport network, using the least amount of resources. Engineers actually study leaf vein structures for inspiration in designing transportation systems, drainage networks, and even advanced materials. That tiny leaf in your hand contains design solutions millions of years in the making. Here are a few surprising leaf facts. Some tropical leaves have vein systems so dense they can continue functioning even after partial damage. Scientists can identify certain plant species based solely on vein patterns, and fossilized leaf veins help researchers study ancient climates from millions of years ago. So why do leaves have veins? Because they're the leaf's built-in life support system, delivering water, moving nutrients, and providing support. What looks like a simple pattern is actually a highly efficient natural design. The next time you hold a leaf, remember, those tiny branching lines are doing far more than just making it look beautiful. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.